the previous lecture we stopped this footage. Now what we're going to do is we're going to substitute the h prime value to the transition probability equation. Remember this equation, we have written it a while back. So this is the transition probability equation, 1 by h cross modulus 0 to t prime e raised to minus I omega I f t bra f h prime of t get I dt and modulus closes with a square. Now what we're going to do is you just have to substitute the h prime value to here and solve it. So we'll first simplify this and then we'll just substitute. So we'll just do this thing and then finally apply to the formula. So this is like h prime is nothing but e naught by omega cos omega t summation q1 divided by mn dot p dt. Yeah, so the thing is that this term can be taken out because as far as I, f and I are concerned, they are time independent eigenfunctions. Okay, yeah. Now what you have to do is we have to okay, so we don't know what this is. This is nothing but the momentum operator, and this can be written in terms of commutative bracket like this. P of n, Pn is equal to commutative bracket R H naught Hamiltonian of the original molecule, and this one, the commutative bracket, acts on a function which gives function f of r gives r comma h naught fr. Why we are doing this is because we don't know the value of the commutative bracket. So in order to solve that, what you're going to do is you just have to substitute the value. So you know h naught is nothing but the minus h cross square by 2m dou square by dou r square plus v of r, which can be also written as 2m del square plus v of r. You just have to substitute this here. You will get it as r h cross square by 2m del square f of r and minus of minus plus h cross square by 2m del square r f of r. Okay, and then that is just the first term. So I just took the Hamiltonian of this term. I have to do it for this term as well. What I did right now is r into first term plus second term. No, so this is the first term, this is the second term. The Poisson bracket property is that I can do it like this. I can split and do the commutation bracket, commutative property, whatever. So I just did the first part. Now to do the second part. To do that, so till now for the first part you understood. No, next is same way, r vr minus v of r. So this becomes 0, so we don't have to think about it. The thing is that r comma v of r commutates, so this thing is gone. But first term is not like that, this doesn't commutate, so we have to solve it. So how do you solve this one? We keep the first term same itself, like minus r h cross square by 2m del square f of r, and the next term we can split it open like into 2m. Del square can be written as del dot del r f of r. Okay, and then just open the, multiply this thing here to here, so it will be like minus r by h cross square by 2m del square. The first term is the same itself, but this one is like h cross square by 2m. There's a del dot outside. This will become del dot r is nothing but 1, because del by dou by dou r of r is nothing but 1. So del here is dou by dou r, so it's just 1 into f of r. So it will be f of r 1 into f of r plus, now this thing into this del of f of r dot r. So we'll write it as r del f of r. Same thing, there's no simplification, so you have to write like that itself. Okay, so what next? Now you have to bring this one inside and do the same. So you will get, try the same h cross, first term the same thing, and the second thing what you will do is h cross square by 2m del f of r, the same thing, plus what do you do, del r dot del f r. So it will be del f r itself, del f of r, sorry, del f of r. Now next one is r del square f of r. Okay, I hope you understood how. Del r is equal to 1 dot del f r, so del f r. Now del into del f of r is nothing but del square f of r, and then the r and r is constant, so you'll bring like this, you will get like this. Okay, fine. Now what you're gonna do is this can be written like this term and this term gets cancelled because one is plus and one is minus, so you will finally get only the term h cross square by m del f of r. That's the final answer. Next, what I'm going to do is that I'll put my ih cross into minus ih cross divided by m the f of r. So h cross square I just did split it into plus ih cross into minus ih cross. So it will be I square is minus 1, then there's a minus plus h square by m. So the same thing but written in a different format. And the one which is written here is nothing but the momentum. So I can write it as ih cross p by m. Fine. So this is the commutative bracket of that one, and using this you can solve further. Okay, so finally I've got the commutative relation. Now what I want to do is you just have to substitute it to this equation over here. You just have to substitute it and solve it. We'll see what happens. If you see from here, this thing, the rest of the terms goes on the other side. So you will get it as by m is equal to 1 by h cross, so you can write it as minus, it's actually 1 by ih cross. The I in the denominator goes up, and while going up it becomes minus, so it will be minus I by h cross commutative bracket r comma h naught. So while substituting it will be like this, and this becomes r comma h naught, and there's minus I by h cross. Yes, and then get I. Fine. Now what we're going to do is we're going to open the commutative bracket, and also I'll just put this minus in the beginning so that it won't be confusing. So I'll just have to open this commutative bracket again, so it will be like RH minus HR, and then you have to multiply the other terms inside and you'll get a form. So we'll see that now. So this will look like this. I'm just splitting and writing it. So what happens is that this will become one term, and then this will become another term. So I'll include this as a different term. So we'll minus, the minus comes here minus, and then the same thing. So this becomes this one, h naught of r, then the ket. I just wrote the commutative bracket in two separate terms. That's it. Now what I'm going to do is you have to see h naught acting on ket of I. We remember this thing gives you ei naught. Same thing you have to apply. Here h naught will act on f, so it will be ef. So sorry, this will be ei because it's acting on ith state, the initial state. H naught acting on f gives you ef I. Now you have to substitute it. You will get it as, so I'll be getting like this. So h naught of I, instead of that I write like this. So this becomes like this. There's no h naught term, only this term changes. The rest of the term is the same. Here ef I ket I comes. So okay, this is ket I. Okay, that's a mistake. So this two terms comes inside. And then what I'm gonna do is, we know that this thing is a Hermitian. Before that, let me just correct my mistake. This is I. Okay, we know that h naught is a Hermitian. What does that mean? Means h naught Rn dagger the same. It's like h naught Rn, the whole dagger is equal to Rn dagger. H naught dagger is equal to Rn h naught. Okay, so it will be the same. That means h is equal to h dagger. Fine. Now what you want to do is, we can write this together. I can write this as, I can write the whole term as ei minus ef ket f, sorry, bra f summation n q n this one ket I. Okay, so I can write that as, write the, actually what is this? Okay, this equation to be as, this is nothing but minus fy. Minus will go in this thing, so become omega fy. This become this, and then h cross get cancel. We can write it in a more eloquent way like this. We can take this omega inside, it will become this, and okay, and then write the rest of the terms like this. Okay, so this is the equation. This is the final equation. We'll stop at this stage and continue in the next lecture.